Assalamualaikum and good morning. Today I'm going to present a case study. My name is QISTINAH binti ZAMZURI, number matrix 03DDT23F1003. So in my team we have FATIN SYAZWANI binti FADILLAH and NURHAWANI binti OTHMAN.
Hi, my name is NURHAWANI. I'm presenting question 1. Identify the primary types of mobile security threat that could affect the application. A. Data leakage, cause user grant excessive permission or input sensitive data, name, address, card number. Risk, data can be stored insecurely and accessed by malicious app or script. For example, a malicious app restore booking form data if not secure. B. Malware and spyware, cause infected apps or browser hijacker. Risk, malware can intercept keystrokes, steal user credentials, or hijack session. For example, a user enters credit card info into your site but a keylogger records it. C. Man-in-the-middle attacks called unsecure public Wi-Fi networks. Risk, attackers intercept data transmission between the user's device and your server. For example, an attacker captures booking info including payment during consumption. D. Insecure data storage, called storing sensitive user input like payment data in local session storage or plain text. Risk, attacker who access the device or inspect the browser can steal this data. For example, credit card data saved in a browser console. E. Cross-site scripting, cause improper input validation. Risk, malicious scripts can be injected into form field and execute on other users' device. For example, a user types a script tag into the special request field. Question 2. Identify the common security risk associated with mobile device. A. Device loss or thief. Risk, if a mobile device is lost or stolen, unauthorized users could access stored personal or sensitive data. Impact, safe credentials, booking confirmation or payment info could be misused. B. Unsecure Wi-Fi network. Risk, public Wi-Fi may expose user to man-in-the-middle attack. Impact, sensitive data transmitted can be intercepted by hacker. C. Outdated operating system and app. Risk, older versions often have known vulnerability. Impact, attackers can exploit these flaws to compromise device security and steal data. D. Malicious application. Risk, some apps, especially from an official app store, may contain malware or spyware. Impact, they can access device data, track keystrokes, or silent monitor activity. And the last, phishing and social engineering. Risk, users might receive fake emails, SMS, or pop-up imitating trusted source. Impact, users may be tricked into entering personal info or logging credentials.
Let's move on to question 3, which is about how the Google Android security model protect user data. First, let's look at the application sandbox. Every Android app runs its own sandbox, which is like a secure and isolated space enforced by the Linux kernel. This means that app cannot access each other data or code unless the user explicitly grants permission. Each app is assigned a unique user ID or UID to keep its data separate. This separation helps prevent accidental data leak and improve overall security. Developers are also encouraged to request and share data in a secure and authorized manner. Next, we have the permission-based access control. To manage access to sensitive information like the camera, contact or location, Android uses a permission system. Starting from Android 6.0, permissions are now requested during runtime rather than only at installation. This change gives users more visibility and control over what data app can access. Developers must explain why certain permissions are needed and ensure the app can still function even if some permissions are denied by users. Third, secure RPC. Android secure RPC mechanism, which use BINTI, intent and content provider, ensure only authorized app can interact. However, misconfigured component can lead to data leak. To prevent this, Android applies signature level permission, allowing only app signing with the same key to communicate privately. Next, Android use file-based encryption to protect user data, mainly through the Android key store system. Starting with Android 10, encryption is enabled by default to improve device security. Cryptographic keys are stored securely in hardware-backed components like Strongbox or TEE. Ensure data safety from tampering or unauthorized access. Last point for question 3 is Google Play and App Sign-in. Google help protect user data by using Play Protect, which automatically scan apps on the Play Store for any malicious behavior. It runs in the background and helps keep both installed and newly downloaded apps safe. Question 4. First, we have the iOS partition or top layer. The operating system core layer includes the kernel and key framework and for security features like sandboxing, memory protection, and kernel integrity. Developers must adhere to Apple API and system rules to avoid app rejection from the App Store. Next, we have the sandbox. iOS apps operate in a sandbox, a controlled environment that restricts access to data or system resources without explicit permission. Developers must declare entitlement and use built-in permission dialog to access features like camera, location, or contact, ensure user privacy, and prevent malicious behavior.
C is developer app. iOS apps require to be signed with a current Apple certificate. One important security feature that guarantees the app's integrity and validity is the code signing procedure. From the perspective of a developer, iOS devices can only launch apps that are reliable and have been properly signed. Developers must sign up for Apple's developer program in order to receive this certificate. Furthermore, if a security flaw is found, this mechanism enables Apple to cancel an app's certificate, stopping it from being installed on user devices. And D is iOS apps. iOS apps include both third-party applications and Apple's own native apps. All of these apps are subject for the same sandboxing and permission models, ensuring a consistent level of security across the platform. For developers, this means that their apps must be undergo a thorough review by Apple to ensure compliance with security and privacy guidelines before they can distribute it on the App Store. Let's move to the next is E, Secure Enclave. The Secure Enclave is a separate processor within the iPhone that is specifically designed to handle sensitive operations. It plays a vital role in managing encryption keys, Face ID, Touch ID, and other private data securely and independently from the maintained iOS system. For developers, access to the Secure Enclave is provided through high-level APIs such as Kitchen without allowing direct interaction. This architecture adds an extra layer of trust and security, particularly for biometric authentication and cryptographic functions. Question 5. Why a mobile device management (MDM) solution is crucial for protecting user data in today's mobile-first work environment. MDM is not just nice to have, it is a must. Here is why. First is data stays protected even when devices go missing. If a phone or tablet is lost or stolen, MDM lets you log it, track it, or wipe the data instantly. No one's getting into sensitive files without permission. Second is full control over what's on the device with MDM. You can decide that what apps can or can't be installed, enforce strong passwords, and make sure devices follow security policies. It keeps everything in line without relying on users to do it themselves. Number 3 is secure access to company systems. Only trusted devices can connect to business apps, emails, and cloud storage. MDM makes sure access is always encrypted, verified, and secure. 4 is real-time monitoring and quick response. MDM lets your IT team keep an eye on all devices in real time. If something suspicious happens, like something trying to root or jailbreak their device, you can step in fast. 5 is personal and work data stay separate. No one wants their employer digging into their personal message. MDM creates a clear line between work and personal use, so the company can protect its data without crossing any boundaries. And lastly is simple updates and consistent policies. Instead of updating each device manually, MDM push updates and policies across the board. Everyone gets the same level of security no matter where they are.